Okay, in this lesson, I'm going to show you how we can use S.O.H.C.A.H to solve quite a few different problems regarding triangles and trigonometry. And we're going to do this using a couple of examples. So, before we can begin, we need to know what the S.O and the C.A.H stand for. Okay, so let's talk about that. If we look at the S.O.H triangle, then the S stands for the sine of the angle. So S stands for the sine of the angle, and we've already used a sine button and we know what the sine is, so that's what the S stands for. O, you can probably guess, stands for the opposite side of the triangle. That's the opposite. And H stands for the hypotenuse. On the other hand, if we look at C.A.H, then the C stands for the cos of the angle, the cos of theta, whatever the angle happens to be. The A stands for the adjacent side. And H, once again, stands for the hypotenuse. Okay, so these are like what we call magic triangles, and the way they work is that we can use them like this. If we wanted to find the opposite side of a triangle using, we'll talk about the S.O.H triangle first. If we want to actually find the opposite side, we would put our finger over the O. And if we do that, we notice that the S and the H are side by side. That means they times each other together. So the opposite side is equal to the sine of the angle times the hypotenuse. And we already learnt that from our previous lessons. Now, on the other hand, if I wanted to work out the length of the hypotenuse, I'll put my finger over the H. And look at this. Now the O is on top of the S. So the length of the hypotenuse is going to equal the opposite length divided by the sine of the angle. And the same goes for the cos pyramid. So if we now go down here and look at our cos, our C.A.H magic triangle, if I wanted to work out the length of the adjacent, then I'd simply put my little finger over the A, and I notice that the A, what's left behind is C and H, and they're side by side. So they times together. So the adjacent will equal the cos of the angle times the hypotenuse. On the other hand, if I wanted to work out the hypotenuse using my C.A.H triangle, I put my finger over the H. So I always put my finger over what I want to find out. I put my finger over what I'm trying to calculate. So if I want to work out the hypotenuse, I put my finger over H, and you'll notice that H equals the adjacent divided by the cos of the angle. And we can now use this idea to solve quite a few problems. So we're now going to do a couple of problems. So let's have a go. Now, I'll need a triangle. There's a triangle. The angle is 30 degrees. This side of the triangle is 8. And the question is, what is the length of this side here? So what's the length of this side? That's the question we're going to ask ourselves. So, how do we use our magic triangles to work this out? Well, we have to ask ourselves two questions. The first question is, what do we want to find out? So we have to ask ourselves, what side of the triangle are we trying to find out? And the second question we have to ask is, what side do we already know, or what do we already know about the triangle? So they're the two questions we need to figure out. I'll just move this out of the way. Okay. So let's put all this together. Now the first step then is to label our triangle. So let's go back to our triangle, and there's our angle. And so we need to label the opposite, the hypotenuse, and the adjacent. Now here's our right angle there, so that could help us a bit of a clue. So this is our angle, therefore this side here is our opposite, so I'll label that O. The longest side of the triangle is H, and it's also opposite the right angle, so there's my H side. The remaining side is my adjacent. Okay, so I've labelled my triangle. And by now looking at this triangle, we can see that the side we want to find, out, is in fact the hypotenuse. So the answer to this question here is H. So we want to find out the length of the hypotenuse. The second question we ask ourselves is, what do we already know? What side do we know? Well, we don't know the adjacent, but we know the length of the opposite. So it's the opposite that we already know. Okay, so we're trying to find H, and we know the opposite. So now we have to work out, well, which of these two triangles do we use? Well, it's actually really, really easy. The triangle that we use, the magic triangle we use, is the one that has these two letters, these two answers to our questions. So the answers to our questions we posed were H and O. So which of these has H and O in it? Well, it's this one here. So we're going to use the S.O.H.C.A.H triangle. So now what we do, we get our little hand out, and you just use your finger if you like. And we're going to use this, we're using this triangle here. Now, we cover up what we're trying to find. Now, what are we trying to find? We're trying to find the hypotenuse. So I'm going to put my finger over the hypotenuse, like that. And so, in doing that, we can now finish the problem. So, by using my magic triangle, I can write my equation. H, the length of the hypotenuse, is equal to O, the opposite, divided by S. So there's my equation. H equals the opposite divided by S. Now we need to know what they stand for. So O stands for the opposite, so it's going to be the length of the opposite divided by, what does S stand for? S stands for the sine of the angle. So it's going to be the sine of theta. Okay, now let's plug in our values. So that's an equal sign, by the way. So what's the length of the opposite? Let's go to our triangle. The length of the opposite is 8. So the opposite's going to be 8 divided by the sine of 30 degrees. Now, if you go to your calculator and work out the sine of 30 degrees, you will find that it equals exactly 0.5. So that will equal 8 divided by 0.5. And if you now finish that calculation, 8 divided by 0.5 is in fact 16. So we have now worked out the length of the hypotenuse. It is 16. And if our measurements were in metres, of course, that would mean that the hypotenuse is 16 metres. So there's our first example of how to use our magic triangles to solve a trigonometric problem. In the next video, we're going to do a few more examples.